Alright, finally, look at it. This is from Ripple on a Cosmic Sea. Search for Gravitational Waves. David Blair, G.F. McNamara. Says from 1997, this book. Adams and Wesley, Helix Books. 1997 copyright. Does that look like a Tic Tac right there? Says here, the resonant bar gravitational wave detector is realized at the University of Western Australia. The bar is cooled a few degrees above absolute zero and insulated from vibration. The transducer using microwaves and superconductivity to read out the vibrations of the bar. It says over here. The University of Western Australia Gravitational Research Team have a bar made from niobium, which is the best superconducting pure element at the Perth lab. It was hoped that the better properties of niobium would allow simple levitation. While the critical field was known, it was not whether the magnetic field would penetrate a lower field, nor was it known how strong magnetic fields would degrade the acoustic properties, of the diameter antenna 37 millimeters long. This was followed by a larger version, a 1 meter long bar, 10 centimeters across. In both cases, the levitation worked beautifully. A set of coils lifted the bars to a height of 1 centimeter. Where they floated freely, completely isolated from external vibrations. The acoustic losses were very low. Typically, they ranged for many hours after being struck. Just what was needed for the sensitive detectors. So anyways, it goes on to say that basically the levitation here, well, I think it says it beforehand over here, the degeneration pressure, as they call it, causes this magnet here to, and the more you try and push it down, it creates what's a degeneration recoil. And that causes it to then levitate and to stay over the source that is causing what they call the mirror magnetic image. Alright? So if you were to, for example, have a disc that was the original bar, and the disc were able to point like this and oscillate any side away, and you were to create strong enough of a signal, then would it make this Tic Tac thing remain levitated over it at whatever altitude they were able to, since 1997, get it to? That would shoot it across the sky, wouldn't it? Very quickly, very fast actually, because it remains absolutely level. It says in here above it. And it said now noise here. It says, well, when once detectors were capable of registering incredibly small vibrations, there remained the problem of how to isolate the resonant bar antennas from external sources of vibration. When magnetic levitation failed, another method to be found. Cryostats were awfully noisy environments full of creaky pipes and metal plates and boiling liquid and air and liquid helium. They must support very heavy loads using the thinnest possible cables to prevent unacceptable amounts of heat entering from the outside world. This makes design very difficult. Let's look at how the Perth design solved. So basically it says here the Perth design has 17 stages. Some consist of lead discs separated by rubber blocks, operating room temperatures, and then it goes on to say here that with the system, you can hammer the chamber containing the bar and drop bricks on the floor without disturbing the piece of the antenna. No wires are attached to the bar. All signals are sent in and out in radar-type microwave beams, so no vibration enters down the wires. So radar-type microwave beams send a signal to this Tic Tac looking thing, Maybe you don't need a little oscillating antenna or a little 360-degree antenna. This magnetic mirror. Maybe they just send a signal right there. And little Tic Tac looking thing there. Maybe it's got more altitude than 3 centimeters now from 1997. Pretty interesting. I look like Tic Tac. That's what it is saying.